So today we're going to talk about ratios in similar polygons. We're going to be able to basically tell the difference between congruent, so two figures are congruent if they have the same shape and size, versus similar if they have just the same shape. Okay? In similar polygons, this is basically what we're going to want you to be able to do is justify mathematically that two shapes are similar. All the corresponding angles are congruent, and the sides are proportional. In other words, they all have the same ratio. Okay, so that's what you'll be able to do here at the end of the lesson. All right, so let's go ahead and move forward here. All right, so these two figures here, the green figure and the purple figure. Okay, so if you look here, I'm going to go from the big figure to the small figure. 3 to 2, is that the ratio the same as 6 to 4? 6 to 4. Well, let's see. 3 to 2 is in simplest terms, so let's look at 6 to 4. Can I simplify that? Yes, 3 goes into 6 twice. 2 goes into 6 three times. 2 goes into 4 twice. So all three of those basically have a 3 to 2 ratio. Okay, so the ratio of the lengths is is good. It's 3 to 2 if I'm going from the green to the purple. That's called the scale factor. If I'm working from the purple figure, the small figure, to the green figure, the large figure, now my scale factor would be 2 to 3. And again, we can express this as 2 to 3 as a fraction, 2 to 3, or 2 dot dot 3. Any of those, just to review, any of those formats are acceptable. Now, I don't know about the angles, but if the angles are all congruent, then those are similar figures. Now, this figure here basically says, are they similar? Okay, make a similarity statement if they are. Okay? So I have to look here. 12 is to 16. Does that simplify to 3 over 4? It does. Shouldn't have said does it simplify to 3 over 4. Into 12, 4 goes 3 times, 4 goes 4 times into 16. Okay? Um, this figures are flipped around, so 12 is to 16 here. KJ versus AD, basically. And 15 is to 20, also simplifies to 3 over 4. 3 goes into 5 goes into 15 three times, 5 goes into 24 times. Okay, so now last one is the 9 for BC and the 12 for LM. 9 is to 12. 3 goes into 9 three times, 3 goes into 12 four times. So 3 to 4, if I'm going from the small figure to the large figure, 3 to 4 is my ratio. Okay? If I'm going from the large figure to the small figure, my ratio, my scale factor would be 4 to 3. Okay? So now, last thing I need to do here, I'm going to need some space down here, so I'm just going to clear that out of there. But we need to make a similarity statement. Okay, I'm just going to call these quadrilaterals because actually they're trapezoids, but you know why that is. They're trapezoids because if you look at figure A, B, C, D, these are 90 degrees each over here, angle B and angle C. So therefore, these lines are parallel, right? I got 180 degrees on the same side of a transversal. Okay, so therefore, this side I got 80 at D, so I must have 100 at A. Okay, and over here in the large figure, this must be 80 down here at J. All right, so now if I want to make a similarity statement, I have to line these things up. Okay, so if I want to call this trapezoid alphabetically A, B, C, D, and say it's similar to, that's your sign for similar to, trapezoid, then look over at this figure here. Let's start at, this figure has to start at K, wherever the 100 degrees is. So K, and then I went to a 90 degree on top, so that must be L, and then we're going to just work around MJ. MJ. All right, and that's what you do to make your similarity statement. Okay, you have to line these up and take a minute to do that. Okay, it's not the only similarity statement you can make, but if you started with trapezoid A, B, C, D, now this right hand side, the large figure, would have to follow. All right, now they're not all going to be similar, obviously, and this is kind of the devil's advocate case. So I've got in the large figure the 10 compared to the six, or small figure 10 compared to large figure 16. Those are corresponding sides. Is that equal to, and the other guy, the 3 to 5? Do those ratios hold is basically our question. All we need to do to check this is cross multiply. 10 times 5 is 50. 3 times 16 is 48. And anytime you have two of your ratios set next to each other and they are not equal, then the figures are not similar. Okay, so the ratios don't hold. All right. Okay. All right. Now this figure right here, the Met's figure to the Yank figure here. Yank is the larger figure, so scale factor. Let's see. We've got the 6 is to the 9 here, so that simplifies to 2 to 3. Those are definitely corresponding sides. Basically SM to KY, if you will. And then nothing else is nice, so I'm going to have to, they told us it's similar. So I only need to find one side that matches up if they tell us this is similar. So I'm going to go ahead and put a 2 in the small figure and a 3 in the big figure, because now I can easily set up my scale factor correctly. Mets to Yang, so the small to large, 2 to 3. And again, I could express it as a fraction or as 2 dot dot 3. Yang to Mets, well, I'm just going the opposite direction for my scale factor. Vocabulary word, scale factor. You need to know that, right? The scale factor is going to be, for this guy, the large to the small. Okay? So now I can use that to go ahead and set up proportions to find ST and YA. Okay? For ST, well, that's compared to the 8. So ST is to 8, its corresponding side in the other figure, as 2 is to 3. 3ST equals 16. ST equals 16 over 3, which is 5 and a third. Okay. YA, I'll just repeat the process here for YA and go YA is to 3, those are matching sides there, as 3, the big, is to the small, 2. So YA, 2YA equals 9. Okay, so of course, excuse me, so then YA therefore equals 9 over 2, which is 4.5. Okay, so that's how you do that. Use your scale factors to set up ratios. All right. I went ahead and if you look in your notes, I skipped the blueprint problem for right now, just in the effort, in the interest of time. Okay, we'll maybe get to that in class, but in the interest of this video, I want to keep this under 15 minutes, so I want to make sure we get this done here. These two polygons are similar. Key information. Find x and y. Okay, so x is here, and they're both in the same figure. Okay, so let's label the figure that they gave us information on here. So these are parallel lines, or the 15 and 20, that's parallel. So if this has to be 120 here, because 120 and 60 add up to 180. All right, so this is the corresponding part here. So I can quickly say, let's 5y minus 8 equals 120 and solve. Okay, so now 5y equals 128, and y is going to be just a not very nice number, so we're just going to leave it as 128 over 5. So 25 and 3/6, something like that. Okay, all right. For x, let's take a look here. Okay, so now we're going to set up a proportion. The matching tops, 15. Let's just go. 15 is to x plus 2. Actually, I take that back for 1 second. I'm going to go ahead and just set this up. I'm going to 15, 20. We're going to go ahead and simplify that right away, just to make our numbers smaller as we work. So we're going to say 3 to 4. We're going to say the ratio of the top to bottom here has to be the same as the ratio of the top to bottom here since they're similar figures. So 3 is to 4 as x plus 2 is to 2x minus 2. So now I need to cross multiply and be careful that I distribute. So 3 times 2x minus 2 equals 4 times quantity x plus 2. First couple times you need to write that step out to make sure that you multiply appropriately. Now we're just solving for x. And 2x minus 6 equals 8. 14, x equals 7. And we did what they asked us to do, solve for x and y. Okay, last one. Okay, again, these two polygons are similar, yay. Find x and y, okay? So let's see, so we need some sort of scale factor here. And we get matching pieces here and here. So 20 to 24 is my scale factor. Can I simplify that? Why, yes. 4 goes into 20 5 times, and then to 24 6 times. So 5 is to 6. And on a quiz or test, it's nice. Just mark your figures that way. So 5 is to 6. So small is to big, 5 to 6, and big to small, the scale factor is 6 to 5. Okay? So now 5 is to 6 as 9 is to y. And we solve for that guy. 5y equals 54. And so uh, y equals 5 is to, let's do it this way, sorry. Oops. 5 is to, let's stay in the same figure. 5 is to 9 here as as 5 is to 6 is 5 is to 9. Here we go. Sorry. Just wanted to make sure I get this right here. So 5 is to 6 as 9 is to y. There we go. That'll work. 5 is to 6, so here to here, as 9 is to y. There we go. Sorry about that. So 5y equals 54, and then y equals 54 over 9, which is not, or 54 over 5. Not a great number, but that's okay. And then the x plus 3. So let's go and go x plus 3 is to 8. Those are the matching sides, as 5 is to 6. Okay, so figure to figure, figure to figure, and we got 6x plus 18 equals 40. And 6x equals 22. And x equals 22 divided by 6. Which is 11 to 3. Okay? All right, we just made it, so hope you're having a good day, and we will talk to you soon.